Hey guys, welcome back. We continue with the book Automate the Boring Stuff with Python, and today we're going to cover chapter 4, lists. You can read the book for free by heading over to automatetheboringstuff.com, or if you prefer a physical copy, there's also a link in the description down below. In this video we are going to cover lists and tuples, and we'll also take a look at methods. So let's get right into it, and let's start our code editor, Mu, to have a look at how lists work. So a list is a value that contains multiple values in an ordered sequence. And similar to how strings, for example, start with a quote character, a list is starting with brackets. So as an example, we can open up our REPL here and just type in some values inside of brackets, and that denotes a list. Instead of numbers, we can of course just enter a number of different strings, and that would also be valid. And we can even include different data types inside of a single list. So for example, here a string, then a float, then a Boolean value true, the value none, and then an integer. And to easily access the values stored inside of a list later on, we can assign it to a variable. And then as we call the variable, the values of the list will be displayed. Now, when we assign a list to a variable, as we did here with the variable spam, we can then reference individual values inside of that list rather than just printing out the entire list. And to do that, we are referencing the index of the list. So each of those values inside of that list is denoted by a certain number starting from 0. So if you take a look at this example here, we can see that if we take the variable name spam and then follow it with some brackets and denote the specific index, we can reference that value. So for example, spam 0 is going to refer to cat, spam 1 is referring to bat, and so on and so forth. One important thing to note is that we should make sure that we don't go outside of the bounds of the index. So the first value here is going to have an index of 0, the next one of 1, the next one 2, the next one 3. But for example, if we try to reference the value of spam with an index of 4, which is not defined, then we're actually going to get an error message. So here we see we get an index error, the list index is out of range. And of course the same is going to be true if we take a much larger value, then again we're going to get that error. Now we can also define lists that contain other lists. So here for example we define a list and assign it to the variable spam, which contains a list of two separate lists. So here we have one list that has the two entries cat and bat, which are strings, and then we have a second list that contains a number of different integer values. And just as before, we can use the index to reference the different parts of the list. If we are referencing the value of spam with an index of 0, we get back the first list, and then we can even change this. So we could say we want to have index 1, for example, inside of that list, so that would give us back bat. So we are first referencing the first element of this list of lists, and then we are referencing the second element by using index 1 of the inner list, and that gives us back bat. And especially if we have a larger list, we can, instead of just referencing the values using, for example, the index of 0 or 1, we can just reference the last value by typing in a negative number. So if we type in spam with an index of -1, we're going to start at the end of our list and referencing the last element. So here we are going to get back the list of integers, which is our last value. And of course, if we were to type in spam with an index of -2, then we would start from the back of the list and get the second element from the back, and that is this list of strings. Now we saw that we can use an index to actually reference a single value from our list. We can also select more than one value from our list by using a slice. So if we have, for example, a list spam that includes 4 values, we already saw before that we can use our index to reference a single value. For example, here when we pass an index of 2 to it, then we are going to get back the value red, which is at position 3. But if we want to get more than one value, let's say for example we want to get back all the values except cat. To do this, we can type in spam and the starting index, which is going to be index 1, which is where we start. And then we should also include a colon and the ending index, which is where we stop. And the ending index is exclusive. So therefore, if you want to include all the values from position 1 here, all the way up to the last element here, which is at index 3, we need to pass in a value of 4, which is just outside of the current index. So this is going to get us back the values with index 1 all the way up, but not including index 4. So by doing that, we get indeed back bed, rat, and elephant. If we want to get back the entire list, we would again type in the name of our list, then the starting index, so we are going to start from 0, and then the ending index. So if we want to have all the elements, we're going to go all the way up to element 4, which is of course not part of the list. So therefore we get back cat, bat, rat, and elephant. If we want to, for example, exclude just the last value, we could do the following. We could say we start at position 0 and we go all the way up, but not including index 3. But instead of doing that, we could also do the following. We could say we start at index 0 and then we go all the way up, but not including the value with index -1. And of course we know that is always going to be the last element. So this way we're going to get back the same values. As a shorthand notation, by the way, if we want to start at the very beginning of our list, rather than typing 0, we can just skip that value and directly type a colon and then the ending value. So here we're going to get back the same as before. That's just a shorthand notation that we can use. And of course the same is true when we are including the values from a certain index all the way to the end. So if you want to go from position 1 all the way to the end, we just need to type in 1 colon. And if we press enter, we're going to get all the values from position 1 all the way to the end. And if we want to return the entire list, we can just type in a colon like this, and that's going to give us the entire list back. Just as we saw before with strings, we can also return the length of a list. And to do that, we again use the len function and we type in the name of our list after that. And then we're going to get back the number of elements inside of our list. Now we can also change values in our list by using the index. So if we have a variable called spam, which is assigned to this list, we can go ahead and change any value. So for example, if we want to change the value at position 1, which is the second element in our list, we just type the name of our list, then in brackets the index, and then the new value that should be assigned instead of bed. As soon as we press enter, that value is changed. And now if we have another look at our spam list, we can see that this value has been replaced and we assigned a new value to it. Similar to strings, we can also perform some mathematical operations on lists. So for example, we can concatenate them. For example, if we have a list with 3 integers and then a list with 3 strings, we can just add them together. That's going to create a new list, which includes the elements of the first list and the elements of the second list. And we can even go ahead and basically multiply certain values here. So for example, when we have a list with those 3 strings here, we can multiply that by 3, and that's going to give us back a list with those values repeated 3 times. So that's similar to how we would do that with strings. That's also possible with list values. Now, of course, we can also remove elements from our list. Let's say we have our spam list here again with those 4 values. If we want to remove, for example, the value at index 2, so the third value here, we can use the del statement. And then after space, we're going to type out the name of the list and then the index at which we want to delete the element. So in this case, index 2. Now, if we now have a look again at our spam value, we can see that the value at index 2, so at position 3, has indeed been deleted. Now at this point, you might be wondering why we need to use lists instead of, for example, using individual variable names. And just to have a look at an example, let's take a look at this program here. So here we have just a very simple program that's asking for different cat names. We have 6 different cat names that we ask about, and we can see we always type out individual variable names and then asks the user to provide some input. So as we run our program, we can type in the names for our cats. And as we do that, we're gonna get back the names of the different cats. So that's one way of doing that, but of course, especially if you want to ask for additional cats, we always have to repeat our code here. So that's a lot of typing that we need to do. As an alternative, we can use a while loop, and we can work with a list to basically enter the names and later on to return them. So here we have a similar program. We have a list that's empty at the beginning, and then we have a while loop that's asking for the name of a cat, or we're asking the users to alternatively not type anything. And if that's the case, then we're gonna stop our while loop here. So we're gonna break out of that. And at the end of the while loop, we are adding whatever the user typed in to our cat names list. And then outside of that while loop, we are going to loop over all the values inside of our list and print them out. So let's run that program. And here again, we can type in different names. And once we are done typing in values, we just press enter when there's nothing to enter, which of course is going to trigger this if statement here, and inside of that the break statement. So we are going to break out of the while loop, and then we get back the cat names that we entered. So here we don't need to repeat as much code, and we have a lot more flexibility because basically we can ask the user to enter as many values as the person wants, and then at the end we are just going to return whatever values have been provided. And in this program we already see an example of a for loop in combination with a list, and that's something quite common. If we think back, when we learned about for loops, we typically used it with the range function. So just to recap, we could, for example, type out something like this. We could say for a variable, for example, I, in range of, let's say, 4, we're gonna go ahead and we print out I. And that, of course, gives us back all the values from 0 all the way up, but not including whatever has been passed to the range function, so 0 all the way up to 3 in this case. And this is because the return value from, in this case, range 4 is a sequence value that Python considers similar to a list. And we're going to learn more about the sequence data type in a little bit. But before that, we could actually rewrite our for loop with what we learned about loops. So instead of using the range function here, we could say for I in, and then we could say we are using a list starting from 0 all the way up to 3. And we're just going to print out I again, and we get the same output. Now, a common Python technique is to use range in combination with the len function and then some list. So let's have a look at an example. Here we have a list called supplies with 4 different values. And then we use a for loop here to loop over the variable I in the range. And then we pass the len function to it, which is taking supplies as an argument. So that basically means we return here the number of elements inside of the supplies list. So here we have 4 elements. So len of supplies is going to return 4. And then of course we basically go all the way up from 0 all the way up to 4 minus 1. So all the way up to 3, which matches the index of our list. So we can use that to actually print out the index, of course, which is the value of I, and then also the value of that list at that position of that index. So if we run this little program here, we can see that we print out index 0, 1, 2, and 3. That's just the value of I when we loop over those 4 values here. But then we can also see by just referencing that index here of that list, we are typing out the individual values, so pens, staplers, flamethrowers, and binders. So that's a very handy way to easily print out the values of a list. And that's one of the advantages of range returning the values starting from 0 all the way up to, but not including the value passed to range, because it nicely matches how lists work and that they are 0 indexed. If you want to check if a certain value is actually inside of a list, we can use the in and the not in Boolean operator. So here we have a list with 4 different strings, and if we want to check if a certain string is inside of that list, we would just type that string and then the keyword in followed by the list. And as we press enter, we are either going to get back true or false, depending on whether that string value is actually part of that list. So in this case, that's true because the string howdy is actually one of the elements inside of our list. Let's have a look at another example. Here we have a list called spam with 4 different values. And if you want to, for example, check if the value of cat is inside of spam, we get back false because of course that's not included. We can also check if a value is not inside of a list. So we would say not in. In this case we get back true because cat is indeed not one of the elements in our spam list. Let's have a quick look at a slightly larger program. Here we have a program that includes a list of 3 different pets, and we are then using an input statement to ask the user to provide a pet name, and if that pet name is included in the list, it's going to type out the pet name is my pet. Alternatively, we are checking here if the provided name that's been collected through the input function is not in that list of my pets, and if that's the case, then we're printing out that we do not have a pet named accordingly. So let's run our program and let's enter some name in here. And let's first enter a name that's not included. If we run that, we indeed get back that we do not have a pet named accordingly. But if we run the program again and we provide a pet name that's actually inside of that list we're checking for, then of course we get back the else statement here so that this is indeed our pet. Now sometimes we may want to take a list and then assign individual values of that list to more easily reference those. And that's called the multiple assignment trick, or technically tuple unpacking. And let's first take a look at how we could manually do that. If we have a list here, for example with those 3 strings here, we could then of course index each of those values and assign it to a separate variable. We of course have our list here, and now we assigned the first value of our list to the variable size. So this is going to reference fat. Then we have color, which is assigned the value at position 1. And then finally we have disposition, which is of course the last string value here. Now that's one way of handling that, but there is a shorthand we can use. We can just separate the variables by comma and then set that equal to the list. We just have to make sure that the number of variables actually matches the number of elements inside of our list. But if that's the case, then we can just again reference those same variables just to their value, so that's a shorthand form that can be quite useful. Now, rather than using the range operation in combination with the len function as we saw before, we can also use the enumerate function together with lists. So here again we have the same list of supplies as before, those 4 different values in our list. And then we are going to use enumerate, which is taking the supplies list as an argument and that's printing out the index as well as a specific item. And the way it works is that our enumerate function returns 2 values on each iteration, the index of the item in the list and the item in the list itself. And this is what we have been using here inside of our print statement. Now we can also use the random module that we learned about before. So if we go ahead and we import our random module, we can then use it in combination with lists. Let's say we have a list called pets with those 3 entries. If we want to select any of those values inside of that list at random, we would use our random module and call choice on it, which is a function. And then we pass the list name to it. And that's going to select any of those values here at random. So if we repeat that, we actually get back different values and those are selected randomly. We also have a way to randomly shuffle the values inside of a list. So again, if we import the random module and then we have a list called people, we can see we have 4 values inside of that. And now if we want to randomly shuffle those values to mix up those values in the list and put them to a random index, and we can type out the random module name followed by a dot, and then we call the shuffle function. And again, we are passing the list to it. And once we have done that, if we now have another look at our list, we can see that the order of those elements inside of the list is now changed, and it has been changed to randomly. Now when we are assigning a value to a variable, we will frequently use the variable itself. And then for example, if we have an integer value assigned to that variable, we may want to increase it. And the longhand way to do that is to do the following. We take the variable name and then we assign it to the variable name again +1. And that of course increases the value by 1. But there's a shorthand way of doing that. instead of typing out spam equals spam plus 1, we can just type spam plus equals 1. And that's a shorthand form for what we see up here. So this is also going to increase the value of spam by 1. And so we can save quite a bit of time. And that's possible for addition. We can also use it for subtraction, for multiplication, and for division. Let's have a quick look at a table of the different operations available to us. So as we just saw, we can use addition by typing out plus equals. We can use subtraction by typing in minus equals, and that of course is the same as taking the variable, assigning it to itself, and subtracting 1. We can also use multiplies equals, divide equals, and even modulo equals. When we work with lists, there are a number of methods that we can use. And a method is quite similar to a function, except it's called on a value. So for example, if we have a list spam with a number of different values assigned, we can then write spam.index, and index is a method that's being called on our list spam. And here the index method takes a value as an argument and checks at which index that value is inside of the list. So in this case we get back 0 because the string hello is at position 0 inside of the spam list. If instead we pass a different value to it, of course we will get back the index of that specific value. So here in this case index 3. If instead we pass an argument to the index method of a value that's not part of that list, then we're going to get an arrow back. So in this case we get a value arrow that tells us that this specific value is not included in the list. If we want to add a value to the list, we can use the append method. And the append method again is called on the list by using this dot notation. And then we pass the value that we want to add to our list as an argument to the append method. And that's going to be added to the end of our list. So now if we have another look at spam, we can see that this value moose that we passed to it has been added to the very end of our list. If instead we want to add a value not to the end of the list but at some different position, we would use the insert method instead. And the insert method takes two arguments. First of all, the index at which we want to add a value, so in this case index 1, meaning at position 2, and then the value we want to insert. So in this case here, if we call insert on our spam list, the value chicken should be added to index 1, so at the second position. So let's have a look, and we can see that indeed in between cat and dog we now inserted chicken as an additional value. Now it's important to note that those methods like append and insert can only be called on lists, not on other data types, for example strings. So if we have a string x which is set to hello and we call append on it, we are going to get an attribute error because our string object here has no attribute append. So we basically can only call these methods on lists, not on other data types such as strings. Now, rather than just using the del statement as we saw before, we can also remove a value from a list by using the remove method. And the remove method works different from the del statement that we used before. If you think back, when we used del, we passed the index to it. Now we are using the specific value that we want to remove. So here we are calling remove and we pass bet to the remove method. And of course we're calling that on the list variable here. So if we confirm this and we have a look at spam, that we can see that the value of bet here has indeed been removed from the spam list. So if we know the index of the value that we want to remove, we would typically use the del statement. And if we know the value that we want to remove, we would instead use the remove method. There's also the sort method that we can use, and that's going to sort the values of our list. So if we have a list here with different numbers, we can call sort on spam. And if we have another look at spam, then we can see that it's ordered from the smallest value all the way up to the largest value. And we can do the same for strings. In that case, they're going to be sorted alphabetically. Now, if instead we want to sort values not in increasing but in decreasing order, we can pass an optional keyword argument to our sort method, and we pass in a value for reverse. So if we set that to true, then we sort our list in reverse order. So here we are starting with the largest value and we go all the way down to the smallest value. Just as a side note, when we are using the sort method here, we can only call that on lists that have a single data type. So for instance, if we have a list here that includes both numbers, integers in this case, and string values, there's really no logical way of how we can sort string values and numbers. So in that case, we are going to receive an error message. So the sort method here is not supported between instances of type string and integer, but if we call it on just a list of strings or just a list of integers, it's gonna work perfectly fine. Now, to see another benefit of using lists compared to what we've been using so far, let's take another look at a program we wrote in the last video, which is the Magic 8-ball program. And here, just to think back, we were using the random module to randomly generate a number between 1 and 9, and depending on which number was generated, a certain string was being returned and then printed out. So as we run this program, we get back a random string here. So for example, ask again later when the number 5 is returned. Now that's one way of going about it, but it takes quite a lot of work, and we are using a lot of if-elif statements. Now that we know about lists, we can simplify that by a lot. So let's take a look at this program, which does exactly the same. Here we can see we are using a list that contains all the different messages that are being printed out possibly. And rather than having to use this long if-elif statement, we are instead just using this messages list, and then we are printing out just a random value here out of this messages list. Here at the end, we are printing out one of those messages, and specifically we are indexing into our messages list, and we are using the randint method inside of the random module to pick a random number between 1 and the length of the messages -1. So this is going to give us one of the values, and of course we take len messages -1 to properly adjust that for the indices of our messages list, because when we get back the length of the messages, of course that's just going to be out of range for the message itself. So basically we have to subtract 1 to properly have that with the index range. Rather than writing it this way, we could also simplify it a little bit further by using the choice method here and passing message to it. So as we saw before, that's an alternative way, and then we get back a random value here out of the messages list. Now, lists aren't the only data types that represent ordered sequences of values. So for example, strings and lists are similar if we consider strings to be a list of single text characters. So strings are considered sequence data types. Let's have a quick look at an example. We have a string here with a variable name assigned to Sophie. And now, similar to lists, we can index them. So for example, if we type name, we get the value at index 0. And if, for example, we type in name at the value of name at index -1, that's going to give us back the last character in that string. We can also, similar to lists, use slices. And we can also check if certain characters are part of a string, like this. And we can even loop over characters in a string. So for example, here we are looping over all the different characters in our name, which is set to Sophie, and then we print out those 3 stars in the character and then another 3 stars. So this is going to give us back Sophie, but formatted in this way. While lists and strings are similar in a lot of ways, they are different in an important way, in that lists are mutable while strings are immutable. The fact that lists are mutable means that lists can be changed, while strings cannot be changed. Let's have a look at an example. If we have a string called Sophie a cat, and we try to change the string, for example, by referencing its index and then setting it to a different value, we can't do that. We get an error message, and here we get the type error that the string object does not support item assignment. And of course we saw before that for lists we can actually make this change. So here we can change the value at a certain index by passing in a different value. So the proper way to quote-unquote mutate a string even though it's technically not mutating it, is to use slices. So here, for example, we have our name variable again, that string, and then we take part of that string by using this slicing approach. We're taking everything from the 0th index up to, but excluding the 7th index here, which gives us Sophie. Then we add the to it, and then we start slicing from the 8th index all the way to the end, and we assign that to a new variable, new name. And now if we take a look at new name, indeed, now it says Sophie the cat instead of a cat. But that's of course not changing the string itself, but just creating a new string out of the parts of the first string and then basically returning that. Now, if you want to work with lists but want to ensure that the list can basically not be mutated, that it's immutable, we can use a tuple instead. And a tuple is almost identical to a list with two exceptions. First, when we create a tuple, rather than using brackets as we saw before with lists, we are using parentheses around the values we are working with. And the second difference is that tuples are immutable, so they cannot be changed. So while we can go ahead and we can reference any of those values, if we try to actually change one of those values, we are going to get an error message. And here we see that a tuple object does not support item assignment just as strings. So while we can mutate values in lists, it's not possible for tuples. Now, to separate tuples that just have a single value from strings, we can generate a tuple with a single value by typing in a comma after that value, and that's going to signify that this is actually not a string but a tuple. So to check on that, we can use the type function, and here we pass hello to it with a comma at the end to specify that this is not a string but a tuple. So here we get back tuple, this is the type. If instead we modify that and remove that comma here, then we can see that's of type string. So that's really important. If we have a single value that we want to map in a tuple, then we would always need to add a comma. Now we can easily switch between tuples and lists by calling, for example, tuple on a list. So here we see we have a list with 3 different values. We can see that because we have those brackets around that. And now if we want to turn that into a tuple and therefore make it immutable, we are going to write tuple, and then in parentheses we pass the list to it, and that's going to give us back a tuple. And the reverse is also possible. So here we are taking the list function and we pass a tuple to it. You can see that because it's in parentheses. And if we press enter, we get a list back. So we can easily turn a tuple into a list and a list into a tuple. Now, as we've seen before, variables can store strings and integer values. However, that's a little bit of a simplification of what Python is actually doing. So technical variables are storing references to the computer memory locations where the values are stored. So if we have a quick look here, we can define a variable and set it to point to 42. And then we could specify a new variable, which is referencing spam. So currently 42. And now if we go ahead and we change the value of spam to 100, we can have a look at the value for spam, which of course is 100. But the value of cheese actually has not changed. If you have a look at that, it still is 42, and that's because we never changed the value of spam itself, but we just basically pointed to a different value. If we actually changed the value for spam here itself, then cheese should also be 100 because we changed spam to 100. But what happened here is that we first assigned the value of 42 to spam, and then we pointed cheese basically to the location in memory that has the value of 42 assigned, and then we basically are pointing spam, the variable, to a different value of 100, but cheese is still pointing to the location in memory that has the value 42 stored. And that's important to note because also integer values are immutable values that don't change. So changing the spam variable is actually making it refer to a completely different value in memory. But lists are actually mutable, they work in a quite different way. So if we now have a list with a couple of different integer values that we are pointing to spam, we can now go ahead and assign the list spam to a new variable cheese. And if we now make a modification here, so let's say at index 1, so which is a second value here, we are changing the value to hello. Then we can have a look at spam, and we can see that the value for spam has now been changed, and also the value for cheese. So in the case of mutable objects such as lists, the actual underlying value will be changed, while for immutable types such as integers or strings, they just point to a different location in memory. And that may not seem that important at this point, but we can run into some really nasty bugs if we don't properly understand that. So we always need to consider whether a type is mutable or immutable. And you may be wondering why that behavior that we just saw with lists is not happening with immutable values like integers and strings. And to understand that a little bit more, we can use Python's ID function. And by using the ID function, we get back the ID of the specific argument we pass in here. So this is basically the ID that uniquely identifies the space in memory that this specific value is taking. And since it's a specific value in memory, it's always going to be different. Even if we run the same call again, we can see that's a different number now, because that's a different address, of course, where it needs to be stored in the computer memory. So with that knowledge, let's have another look at what actually happens when we work with those immutable values such as strings and integers. Let's take a variable and let's call it bacon, and we assign it the value hello. Now if we call ID on bacon, we get the specific address in memory. So bacon, the variable, is pointing to hello, which has this specific address in memory. Now let's go ahead and let's make some change to our bacon variable. So here a new string is made from hello and adding world to it. And now if we have a look at the ID of bacon, this is now not the same location in memory as before, but it's a different number and therefore in a different slot in memory. So therefore, by taking this operation, we actually didn't change bacon itself, but we generated a new string which has a different address in memory. And let's contrast that to what's happening with lists. So if we define a list X, and we have a look at the ID of that list, we can now make a change to that list and, for example, append a value to it. So now if you have a look, X indeed has 3 values in it. But if we take a look at the ID of X, that's still the exact same number as before, and therefore we know that we actually changed that X variable itself, that specific object. It's not just creating a new value that's stored in a different place in memory, but it actually changes exactly that list. And just to contrast that, if we now create a new X variable and set new values to it, then of course, once we call the ID on that, that's going to have a different ID. So here we are creating a completely new list, but as we do perform operations on our original list, that's not creating a new list, but that's changing the existing list. Now, references are particularly important for understanding how arguments get passed to functions. So here we have a small little program, and in general, when a function is called, the values of the arguments are copied to the parameter variables. For lists, that means that a copy of the reference is used for the parameter. So here we have our X function that takes some parameter, and then inside of that function we are appending the word hello. Now we have a list with 3 different values assigned to spam, and now we are calling the X function and we pass spam to it, and then we print out spam. And as we run our program, we can see that we print out not just the original spam value here, 1, 2, 3, but we actually see that hello is also printed out. And that shows us that as we call this function here, we are passing that list as an argument to that function, and we are actually passing the reference to the original spam list here. That means any change that is made inside of that function actually changes the original spam list, and therefore we get back this list that actually has been changed. And that's called pass by reference. There's also a concept called pass by value, which is the case with immutable objects. So there we basically just pass a value in between back and forth, and that would actually not change the original value here, but give us back basically a copy. But in the case of lists, we are actually changing the list itself. Now, while passing around references to our list is often the easiest way to deal with our lists, and also stick channels, which we're going to learn about in the next video, we may actually not want to perform changes to our original list. And for this, Python actually provides a copy module, which can be used to copy the values of a list rather than passing the direct reference to the original list. So let's take a look at a quick example. We are importing the copy module, and then we are specifying a list with 4 different string values. And now let's have a look at the ID, and we can see this is the address in memory that we get back. And if we now create a copy of our spam list here by calling copy on the copy module and assigning that to cheese, we can now have a look at the cheese variable here, and we see that's a different address in memory. So by taking this approach, we basically copied our spam list here, created a new list cheese, and now of course we can make some changes. So let's say, for example, we are going to change the value for cheese at index 1. We are changing that to 42. And now if you have a look at spam, we can see that the spam list is not changed, it's not modified, and that's because we used that copy function before. However, if we have a look at cheese, we can see that here the value at index 1 has been modified. So whenever we want to avoid actually changing the original list, we can use that copy function. That can be very useful. And if the lists that we need to copy contains lists, then we use deep copy rather than the copy function. Now let's continue with the practice questions. The first practice question is, what is open bracket, closed bracket? So that would be a list, specifically an empty list. How would you assign the value hello as a third value in a list stored in a variable named spam? So we are going to assume that spam contains those integer values, and let's just copy that. Let's head over to our editor and assign that to a variable spam. And now we are going to assign the value hello as a third value to that list. So we now, in order to get the third value, which would be 6, we need to take spam index 2 because that's 0 based, and that indeed gives us back 6. So here we can say spam 0, we are going to set that to hello. And now if you have another look at spam, we can see that now at position 3, index 2, we replaced 6 with hello. Now we have a couple of questions where we should assume that spam contains those values here, a list with those values. So let's do that. And the first question here is, what does this expression here evaluate to? Let's just copy that over. And before we execute that, let's just have a look. We see that we are indexing into our spam list here because we have those brackets here. Let's start in the innermost section here. We see that we have a string of 3. We multiply that by 2. So because we have a string here and not an integer, basically we are adding 2 3s together, so it's the string 33. We're turning that into an integer, so now we have the number 33, and we have an integer division by 11, so 33 divided by 11 is 3. We are turning that into an integer, so we have spam 3, so we are checking out the value of spam at index 3, so that should be the letter D. And indeed that's what we get back here. Next we should have a look at what spam index -1 evaluates to. So we know that if we have a negative value, especially -1, we start at the end. So -1 should give us back D as well. And that's what we get back here. And next we should check what spam, and this is a slice, so :2 gives us. We know that when we don't have a number before the colon, then we start at index 0, and we are going to index 2 but not including 2, so basically we start at 0 and we go up to 1, we don't include 2, so we should get back the list A, B. And that's exactly what we get back here. So for the next 3 questions, we should assume that we have a list bacon that has the following values. So let's add that in here. The first question is, what does this expression here evaluate to? So we call index, the index method on bacon, and we pass the value of cat as an argument to our index method here. So the index method gives us back the index at which this value here is found inside of our list. So in this case here, cat is at index 1, 0, 1. We have cat showing up twice, but the index method is going to return the index of the first occurrence of that value, so therefore we should get back 1. Now the next question is, what does bacon.append99 make the list value in bacon look like? So we know that the append method here adds a value to the end of the list. So here we have that original bacon list and we just add 99 to the end of it. So if you now have a look at bacon, we can see that we added 99 to the end of it. Now next, the question is, what does bacon remove with the argument cat make the list value in bacon look like? So the remove method here is going to remove the first occurrence of this argument that we pass to it. So in our list here we have cat twice at index 1 and at index 3. Now in this case we are going to remove the value at index 1 here, the first occurrence of cat. So therefore this value should be removed and the second value of cat should still be in there. Let's have a look at that and we can see indeed that the first value of cat has been removed, but the second value is still in there. Now the next question is, what are the operators for list concatenation and list replication? So if we think back similar to strings, we have the option to concatenate lists. So let's assume we have two lists here. One has 3 different string values, and the other one has, for example, 3 integer values. We can now basically add them together, and that's going to create a new list with all those list values combined. We can also go ahead and take a list and, similar to strings, multiply it. So here, when we take, for example, this list with the 3 string values here, and we multiply that by 3, we get a new list with those 3 values here replicated 3 times, and is combined to a new list. Now the next question is, what is the difference between the append and the insert list methods? So we know that append is going to add a value to the very end of the list, while insert is going to add a value to the specified index position. So for example, insert 1, cat, for example, will insert the string cat at index 1. Now what are the 2 ways to remove values from a list? We have the del statement that we can use to remove a value from a specified index, and we have the remove method that we can use to remove a specified value, as we saw before. Now next we should name a few ways that list values are similar to string values. Now we saw that those sequence types we are working with, like strings for example, have similar properties to lists in that we can actually, for example, reference their indices, and we can also slice them. So as an example, if we take a string, for example, hello, we could have a look at index 2, which should be the character L. We could of course also slice them. For example, we could have a look at index 2 and take a look at all the characters until the end of the string. So here we get back LLO, and we could even loop over characters in that string. So here, for example, we could write for each character in our string hello, we want to print out that character, and that's gonna give us back hello, each character printed in its separate line. Now, what is the difference between lists and tuples? We learned before that lists are mutable, while tuples are immutable. That means we could change the value of a list, while we cannot modify any of the values inside of a tuple. Now, how would we type the tuple value that just has the integer value 42 in it? So we know that a tuple is constructed by using parentheses and then the value, but in order to make sure that this is actually a tuple and not just an integer, we need to add a comma to it. And just to verify that this is actually a tuple and not an integer, we could use the type function and then pass parentheses 42 with a comma to it. And that gives us back type tuple. If we do the same and we just remove the comma here, we see this is actually an integer. So we need to make sure if you have a single value for a tuple, we always need to add the comma. How can you get the tuple form of a list value? How can you get the list form of a tuple value? So we learned before that we can use a tuple and list statement respectively to turn a tuple into a list and a list into a tuple. So as an example, we could say we want to turn the tuple 1, 2, 3 into a list by using the list statement, and we get back a list here, which we can tell because of the brackets. And of course we can also turn a list into a tuple by using the tuple function here, and that's going to give us back a tuple. Variables that contain list values don't actually contain lists directly. What do they contain instead? So variables that contain list values, quotation marks, would actually have a reference to that specific value in our list. And therefore, if that value is modified, that would also be modified in that variable. And that's because lists are mutable. Now, what is the difference between copy.copy and copy.deepcopy? So the copy function and the deepcopy function, both are being used to copy lists and to avoid that pass by reference basically that lists have by default because they are mutable. The difference is basically copy would copy a list itself and deepcopy would copy nested lists. So whenever we have nested lists that are deeper, then we would use deepcopy, otherwise we would use the copy function. Alright, let's have a look at a couple of practice projects. The first practice project here is called comma code, and let's assume we have a list of values like this, for example a list containing the strings apples, bananas, tofu, cats, and we should write a function that takes a list of values as an argument and returns a string with all the items separated by a comma and a space with and inserted before the last item. So for example, if we take spam as an input, the list above here, then that should return apples, comma, bananas, comma, tofu, comma, and cats. And our function should also work with other lists of different sizes, and we should also be able to cover the case where there's an empty list passed to the function. So let's have a look at that. We have our list here with the 4 different values, and then we need to define a function. So in this case, we are just calling it join list. We take a list as an input, and we have a number of different cases. So first of all, of course, if we have an empty list that's passed to it, we are checking for the length of the list, and if it has a value of 0, so that means that it's an empty list, then we are just going to return an empty string here to cover that edge case. And also if we have a single word, then we are just going to return that word, and we are checking for that again by calling len on the list that we receive. In the other cases, so if we don't have an empty list or a list with just a single word, we have a while loop here, and here we are checking if the length of the list is greater than or equal to 2. That means we have at least 2 words inside of our list. And if that's the case, we are using, in this case, the pop method, which is another way to remove a value from a list. And here we can specify that this should remove a value at the beginning of the list. Just to make that a little bit more clear, let's actually open the REPL. And let's take our spam list here, and let's just say we are calling pop on spam. By default, that's going to remove the last value of our list. But if we pass a value of 0 to it, then we can see that gives us back the first value, and that's also going to remove that value from our spam list. That means spam is now shorter because those values have been removed. And of course, that's going to have an impact on the length of our list. So whenever we pop off a value, the size of the list decreases by 1. So in this case here, while our list contains at least 2 words, we are going to remove the first value at the beginning of the list, and then we are going to add a comma to it. And while we do that, we add those values to joined, which is our empty string. So we add the first value to it, for example, apples, and then a comma. And we keep on doing that until there are fewer than 2 words in there. So here we would keep on doing that with our spam list until we basically just have the value cats in our list. Then we add and to it, and then we finally just join now the first element of the list, which of course is the only element that's left after we basically popped off all the other elements. And then we return that joined list at the end. So let's run that with a couple examples. So first of all, we are calling join list and we pass the list to it that was given to us in the exercise. Then we also have a case where we just have two values, the case where we have a single value, and we also pass an empty list to it. So let's run that. And we can see that in the case of passing spam to it here, we see it's properly separated by comma and the last value here has an end in front of it. The second one here properly returns apples and bananas. And then we have apples in the case if we just have a single value, and if we have an empty list, then of course nothing is returned. The great thing here is we could just add anything to our list here, for example another word. We run that again and that's properly working. So now we have a total of 5 values in here, so this can really handle all the cases no matter how long our list is. The next exercise is called coin flip streaks. So here we are conducting an experiment. We are simulating a coin flip that we flip 100 times, and we always write down if it shows heads or tails. So we are going to simulate those kind of coin flips, and we want to predict what the likelihood is that we have a streak of 6 head values or 6 tail values in a row in the coin flip. And we assume that we are interested in having a sequence of at least 6 times heads or 6 times tails in a row. And to actually get a more predictable outcome, we are not gonna run this experiment just one time and do 100 coin flips. Instead, we are going to run it 10,000 times. And then we are going to calculate the likelihood that we have at least 6 times heads or 6 times tails in a row in a coin flip of 100 times. So let's have a look at that. That's one possible way of addressing that. Here we have a Boolean value called contains streak, which is basically checking if we have a streak of 6 times heads or 6 times tails in a sequence of flipping the coin 100 times. We also have a list here that contains the actual coin flip, so whether we received head or tails while flipping it. And we have an integer streak that's basically keeping track of repeated values one after another. So taking the starting code here, we are starting off with a for loop. So we need to flip the coin 100 times. So we have a for loop for I in range 100. And then we use the randIn function on the random module to get back a value of 0 or 1. And 0 could be heads and 1 could be tails, for example. And we are going to append that value to coin flip, so to our list here. So at the end of that, we are going to have 100 values inside of our list. It's going to be a list of zeros and ones. And now we are interested in checking if there are at least 6 zeros in a row or 6 ones in a row. And that's going to symbolize a streak. So next we are looping over all the values inside of our coin flip. And we are basically checking if the coin flip at index I, which of course is going to increase on each loop, is equal to the value at position I minus 1. And if that's the case, that means we have basically 2 zeros in a row or 2 ones in a row. And then we are going to increase streak by 1. And if that's not the case, then of course our streak ends. For example, maybe we have head, that would increase our streak value here to 1, but then maybe it's tails next. So that means we would reduce it back to 0 and we start all over again. Of course, we still need to cover the special case of having a value of I of 0. We can't really compare the 0's position to the minus 1's position because it would give us a wrong output, so therefore we are just going to pass that loop's iteration and continue with the next comparison here. And if we have a streak of 6, so if there are 6 zeros or 6 ones in a row, then we're going to set contains streak to true. And that's a Boolean value because we are only interested to see if we have a streak in our 100 coin flips, even if there's more than one streak. So if we have 6 times heads, then something else, and additionally 6 times heads or 6 times tails, we still are just going to say we have a streak within those 100 coin flips. So we are setting that to true. And after those 100 coin flips, we are then, if contains streak is set to true, that means if we had at least 6 times heads or 6 times tails in a row, then we are going to increase number of streaks by 1. And then of course, before we continue with the next run through our experiment, so the next iteration out of our 10,000, we need to set coin flip back to an empty list so that we can start all over again. And then also we need to set streak back to 0 and contains streak back to false because we're starting all over, so there's no streak as we start out. And that's pretty much it. So at the end of that, we have our number of streaks that have been incremented, and we are dividing that. So as we run our code here, it takes a little while to execute, but then we see the chance of having a streak in there. So here it's at 45.56%. And when we run that again, it's a slightly different value, but that's actually the mathematical likelihood. It's around 45-55%. The final project here is called Character Picture Grid. So here we have a list of lists where each value in the inner list is a 1 character string, like this. And what we should do is we should take this list of lists and print out this kind of grid value here based on the individual values inside of those lists. So to do that, we get our list of lists as a starting point. And now what we need to do is we need to basically loop through the individual lists. Specifically, we have to loop through the individual values of those lists and basically print those out. So to start out, we have our for loop here, and we first of all take a look at the individual columns. So basically we take the first list inside that list of lists, this one here, and we have a look at how many elements are in there. So that's what len does. So we need that. And then we also need, of course, the number of rows, which we can get by getting back the length of the grid list here itself. So that's going to give us back the number of lists inside of that list. And then we are going to print out those referenced values. So we are having a look at the specific row. So for example, here, the third list inside of that list of lists. And then we are having a look at the specific value inside of that list. And in order to make sure that we don't always print a new line, we add the optional keyword argument end and set that to an empty string. And then after each for loop here, we are printing an empty string, which also creates a new line. And if we run that, we can see we get exactly that output. So in this video, we learned about lists and how we can work with lists. We also learned about tuples and sequence types, and we learned that lists are mutable, while tuples and sequence types such as strings and integers are immutable. We also learned about important methods we can use in combination with lists. In the next video, we are going to learn about an additional data type, dictionaries, and how we can work with that. Feel free to subscribe to stay up to date and be notified about new videos that are being released, and see you guys in the next video.